Alright guys, welcome back. Now today we will again extend our lecture where we left off, and let me start something. Alright guys, just wait a minute. Yeah, so we were building this EDK agents, right? In previous lectures. Then now we will study some advanced topics in this. Okay. Uh, Now we will discuss these topics. One is multi-step planning. Then we have dynamic routing. Alright. Then we have agent memory. Then we will take a look at reflection and self-critic agent, right? And parallel execution. Alright. So in last lecture we built an orchestrator, right? Orchestrator which fetches the Google Trends via MCP. Then we delegates the research agent, right? To a specialist agent via A2A. which writes a blog post using self-correcting loop agents, right? Today we make it like very smarter, dramatically smarter. We will add five things that separate toy demos from production system, right? So we will have multi-step planning. The agent creates a full plan before it acts. Okay, and we implement this dynamic routing. Like agent will decide which agent to call, right? Which specialist to call based on what the task needs. Then we will add agent memory. The agent will remember the past conversations and improves over time. Okay, and reflection and self-critique. The agent evaluates its own output and rewrites it if needed. Then we will implement the parallel execution, multi-step, multiple agent will run simultaneously. Okay, they will cut wait time by 70%. Like that. So we extend the last project we were building in the last lecture. Okay, from there. So multi-step planning. Okay, what is this multi-step planning? So right now orchestrator is there, right? Orchestrator is there, right? Right now orchestrator straight jump into action, right? Jump direct. Like user says the topic agent, then agent will immediately call the trends and calls research, calls planner and calls writer. Then so let's say user says some topic, then what will agent do? Agent calls trends, right? Then it calls research. After research it calls planner, then it calls writer, right? This works for simplest tasks, but for complex tasks, write a 10-part series, build a content strategy for a product launch, create a like a curriculum, jumping straight in product produces the silo output, right? So think of how a professional consultant works. So you don't hire a like consultant, okay, just do your work and start typing the report. That's not how it works, right? So first they will say like, okay, let me understand the scope. Here is my plan. Step one, I will interview stakeholders like that. Then step two, I will analyze competitors. Then they execute like that. Okay. So multi-step planning means the agent will create an explicit plan first as its first action. Then before doing any work, that plan guides everything that follows. Okay. Planner agent, a dedicated agent whose only job is to create a structured execution plan given a goal, right? Like that it will not write anything, does not research anything, okay, publish anything, nothing. It will only plan. Okay. Then what is dynamic routing? Wait a minute, just Alright, then what is dynamic routing? So let me tell you. Uh, so our all current system, what it does? Okay, what it does? It goes from trends, right? Then it goes for research, then plan and then write, right? Then plan and then write. So it's a fixed sequence every time, right? But what if the user says like fix the grammar in this blog post? Okay, we do not need trends in that case, right? So and we don't need research for that. We just need editing, right? So what if the user says translate this post to Spanish, for example? Again, now we don't know any trends, no research, just translation, right? So what I was saying is dynamic routing means that agent will look at what the user actually needs and routes the right specialist for it. Okay, not always the same fixed path. Like think of a hospital triage nurse, right? So they do not send every patient through the same sequence, right? Like blood test and then X-ray or then surgery. So first they assess what's needed, then they will route accordingly, right? So the broken arm straight to X-ray, a heart attack goes straight to ICU, right? A cold goes to general doctor. That's how it works. So there will be a router agent, an agent that needs that will read the user's request, then it will classify it and then decide which downstream agent and tool path to invoke, right? What is agent memory? Every time you start a new conversation, our current system, it remembers nothing from before, right? You have to re-explain everything. So write a blog about AI agents in healthcare. And next day write a follow-up post, right? So agent follow-up of what? Agent will ask to you. I have no idea that what you wrote before. So agent is forgetting here. So to rescue from this, agent memory comes into the picture, and we give the agent a persistent store that holds facts extracted from the past conversation, right? And Alright, then so agent memory will come into the picture and solve this. We will give the agent a persistent store, right? And that hold facts extracted from the past conversations. And when a new conversation starts, right, the relevant memories are loaded automatically in that case. Okay. Think of working with a long-term colleague. When you walk into Monday morning and let's continue from where we left off Friday. They know exactly what you mean, right? So they remember the context. Agent memory gives AI that same continuity. Memory store, it will have a persistent key value store, in our case a JSON file for free, Redis or Firefox in production, where the agent reads and writes facts across sessions, right? Reflection and self-critique. What is that? So our loop agents are, from the previous lecture we understand, like they are doing the basic validation, right? They check like, okay, if basic outline has right structure or not, right? But that is the mechanical checking, right? Reflection is different. It is a qualitative self-evaluation. Is this argument compelling? Is this explanation like actually clear or just long, right? Would a reader finish this or stop at paragraph 2? Right? Is this a tone consistent or not? Think of how a good writer works. Like they write a draft, then they read it as a reader, not as a writer, right? And ask, would I actually read this? Is this interesting? Is this interesting? Does this section drag? Then they rewrite it specifically to fix what they found, right? Then we will have critic agent like that. Okay, then just a minute. Okay, then we will understand the physical, no, parallel execution, right? Currently, our system does everything sequentially, like each step is research, then wait, then plan, then wait, then write, then wait, right? Total time is sequential. But some of those steps are independent, right? If we need to research, they research three different angles for a blog series, right? So those three research charts have nothing to do with each other, right? They can all run simultaneously. So, like research topic A, research topic B, research topic 3, we can do them all parallelly, all three topics, right? So, parallel agents using async IO and gather. This is the let me tell you. Okay, so this is a async IO dot gather. Alright, this is a function to run multiple agents continuous or a co-routines agent coroutines simultaneously and wait for all to finish before continuing, right? So Okay, so new architecture would be our like this. Okay, let me explain everything. New architecture will look like this. We will have a user input, right? This is the user input. Then we will have a uh, router agent, right? This is a new agent. We are introducing this new. Alright. This was not in previous architecture. It will read the request and classify, block, edit, or like what to do with it, right? And after that, we will have this learner agent, right? This will plan for us, creates a explicit like multi-step execution plan. Then it will write the plan to the session state. After that, we will have this execution. Depends on the plan, right? Okay. Like everything, okay, whatever the previous we have. And after that, all of this uh, after every session, wait a minute, don't like this, let me write this like this is memory update, okay. After every session, save the learned facts to memory store. Okay. So yeah, we have to find some new files we have to create. Okay. So let's go to VS Code and start implementing this. Alright. Okay. Let me. Alright. Okay. We are in the right terminal. And everything is correct. Okay, then we will create a directory, new directory. Okay. Make directory advanced because we are advancing it. Okay. Advanced. Then clear into this clear. And then touch. Wait a minute. Then we are touch advanced slash init.py, right? One more thing, and then we have touch advanced slash router.py, then we have plana.py, then trick.py, and parallel.py. Alright, everything is done. What? Oh, it's a mistake, guys. Let's move them all here. I will create them separately, right? It's not working like this. So now that is done, we have lana.py also. Then we will have critic.py. Then we have parallel.py, right? Alright. Okay. Also, we have to create this memory store also. Okay. And inside this touch in the orchestrator, right? Orchestrator slash memory.py. Alright, you can see like here it is. Okay. And one more thing I need to install is AIO files. Okay, let me, this is new dependency be here. AIP install AIO files. I will tell you why we are installing this. Okay. Alright. First we will code this file, guys, which is memory.py in orchestrator, right? Let's start. So this will give our agent the persistent memory across the sessions. So what it will do is that it will read and write a JSON file that store facts, right? So the agent has learned from the past conversations. Why we are using JSON file here? Because it's free and no database needed here, right? And it will work everywhere. In production, we can replace this JSON with the Redis database and Firestore or any key value database. Okay, the interface stays the identical in that case. Now, like import JSON, right? So first we need to import JSON here, because JSON.loads and we have to convert this JSON in dictionary and dictionary in JSON file, right? So we can store memory as JSON file on disk. So when we have to use this anytime you need to serialize Python objects to disk or send them over a network in a standard format, right? Alright. Then I will import OS, because so there will be a function like os.path exist, right? It will check that okay, if the memory file exists before or not, and then trying to open directories, os.make directory, create directory like this. Okay, if needed. So we have to use this import OS when file system operations that depends on the OS, right? So that's why we need this. Then we import async IO. Alright. Why we are using it? Because we use async IO.log to prevent two concurrent operations from writing to the memory file at the same time. Okay. So the race condition is avoided. When to use this async IO.log? Because when any shared resource accessed by multiple async functions, right? So that's why. Then we will have import date time to get the timestamp empty memory, so we know that when it was created, right? Proceed to for experiencing expiring old memories and sorting by recency also. Then we from typing uh, we have to import dict, then list, then optional also, then any. Okay, like type hence make the code self-documenting and catch bugs, right? So dict is means a dictionary with string keys and any values, and optional str means either a string or none. So memory file. Just a minute, guys. Alright, then we imported this. After this, we will have this, guys. Let me check you. Memory file is equal to agent memory dot json. Okay. So it will decide the file path where the memories are stored. So we put it in the project root, so it persists across runs, right? So so it's a constant. So we will define it once here, so we can change. Okay, it is the one place if needed, rather than having the path scattered in multiple functions, right? So that's why. Alright, then we are taking lock here, equal to async io dot lock. Okay, so this lock will prevent two async functions from writing to the same file simultaneously, right? So without this, if two agents try to the same memory at the same time, right, so one could override the other's change, right? So async.lock, async io.lock, this it's an async mutex. Only one coroutine can hold the lock at a time. Other will wait until it's released, right? So why it is module level? Because one shared lock for the entire module ensures that all functions in this coordinate with each other, right? In the entire module. Okay, then we will have guys this async io def, wait a minute, async io define, right, load memory function here. It will return a dictionary that in str will be the key and n is the any type of is the value. And this is the doc string for this. Okay, what happened? Okay, alright, this is the doc string for this guy, which is tell about this function. So loads all memories from disk, okay, and returns a drift with keys. Okay, we have to tell that keys comma facts like this, and references comma topics covered like this. Okay, user context. Okay, return empty structure if a file doesn't exist. Okay, so what it is telling here, we are this will return with the keys. Okay, and topics could be like in the values it can have, it will have facts, it will have preferences, it will have topics covered, it will have the user context, everything, right? If the file does not exist, then it will return the empty structure. Okay, in that file. Okay, or then why async def is here? Because why it is here? Because file IO is an async system, should be non-blocking there, because in a real system we would use AIO files for truly async file reads. Okay, here we use this async read inside async because acceptable for small files here. Alright. Alright, then we have this we have it if not os dot path, okay, dot exists memory file. If this does not exist, then first time running, right? No memory first file yet. Like if we are running first time, so return a clean empty structure rather than crashing with the file not found error like that. Okay, so in that case we can return like this, return facts as empty structure. Okay, why we are using list here? Because facts are things learned, right? Like use the prefer technical depth. Alright, then so each fact is a dictionary. Fact, then key values. Okay, time stamp and everything. So again, it can go for like this. It can also do like appearances. Okay, like this. It will have a dictionary. This is dictionary, so it can have key value pair like for preference. Like example, okay, how what is the tone it would like formal or a depth expert like this. Okay, audience engineer like this. Then it can add like okay topic covered like this. And this also it will use the list empty list. Like it will track. It would have stored the topics we have already talked about. Right? It will prevent the agent from suggesting the same topic twice. Then it will have user context. Alright. So like general context about user, their industry goals, right? Like this. This is how we can return it if it is there like that. If it is not like that, then async with the log. Okay, it will acquire the log, then acquire the log before the reading file, right? Even for reads, we log prevent the reading while a write is midway. Okay, so async with the async with this is will automatic this async with will automatically releases the log when the block ends. Okay, so even if the exception is raised, same as try finally but cleaner. Okay, now we have this block, then we are try with open memory file. Okay, in read mode and encoding is equal to UTF-8. Alright, as F. What is this? Why we are using UTF encoding at 8? So it's explicitly specifying encoding to handle the content with non-ASCII characters like emojis, accent, letters, everything. Without this, different OS default cloud causes the decoding error. Okay. And now we have this data is equal to JSON.load F, load the F. Why we are using the JSON load F? That's why we have imported the JSON above, right? Because JSON load F reads the entire file and parses it as JSON, and it will return a Python dictionary or /list, and it will raise the JSON decoder error if the file is corrupted or contain any invalid JSON. Okay, now it can return the data. Okay. Try then accept is like if it is then a problem here, JSON decoder error, right? It will send the error. If the file exists but the contains invalid JSON, something like that, like okay, if the JSON is corrupted after a crash midway, right? So it will return the memory rather than empty memory rather than crashing. Okay, so what it will do, it will like print a message like okay, memory store. Okay, memory file is corrupted, starting fresh, like this. Alright, then it will return like facts, like empty, right? Then preferences, like empty dictionary here. Then it will have topics covered, right? Empty list. Then it will have the user context, like this. Alright. One more except we can line like except exception as e, okay, like print, and if any other exception is there, okay. Memory store could not load memory, like this, okay, like this. This is the error, like, and it will return something. This something, okay. It will return the same thing here. Alright. Now again we have to alright. Alright, then we have this another function we will type, okay. We will async def will say memory function, right? Memory is dict tr or any, right? Rule, like it will say, okay, save the complete memory directed to disk. Then it will argue about memory, the full memory directed to persist, right? And what it will return? True if you save the successfully, right? And if it will return false if otherwise anything. Okay, like this. Then we will have async with the lock. Wait a minute guys, just alright, what happened? Alright, like this and alright, so we have to acquire the log before writing, right? So if two saves happen at the same time, then it can run into the race condition. Okay, now in this we will try accept log also with open range. Right, then open what we have to open. We have to open the memory file with the right permission, and coding is equal to UTF 8 again as F. Okay, so this will be a new function here. Alright, then this will be a function which is json.dump memory what happened? What? Memory. Alright, memory comma f comma indent equal to 2 and ensure sky is equal to false. So why we are using this json.dump function here, guys? Because it will write the Python dictionary as a formatted JSON. Okay, indent 2 is like pretty print with 2 space indentation for human readability. Without this the entire file is one unreadable file line, so that's why. Then ensure sky like false, because allow non-sky characters also, emojis like Chinese etc. To be written as in rather than escaped like /u XXX sequences. Okay, after this writing it will return true. Alright, and after returning this we have this accept block also. Okay, accept exception as E like this, print like okay, bring f string memory stores code not save memory right, with the error e, okay, return false also, right. Then we will have this one, async def add fact like this, okay, fact str add facts to memory, okay, like it will add one new fact to the memory store, okay. Argument, it will take the facts, fact is key and a string describing, alright, something learned, alright. For example, like use a paper post with code examples like that, okay. Why we are using separate function here? Because of convenience. Caller don't need to load, modify and save manually, okay. So this does it for all in one call. So now what we will do, okay, memory is equal to await, it will load memory first, load memory, it will call that function. Await means like load memory is the async function, so we must await it to get the result first. Then there is a new fact in the chat, so new fact is like, okay, fact is the key here, okay, this is fact, okay, by actual content of the memory, okay. Then it will have some timestamp also, so about the fact, okay, just a minute. It will have some timestamp like this, okay, like data, data not date, date time dot date time date time date time dot now dot ISO format, alright. It will record when was the learned enables, okay. Sorting memories by recency, expiring old memories, this will help with those, okay, in the debugging, like when we learn this like this. This is the new fact, right? After this fact we will have memory and facts, okay, not append this new fact, alright. Why append? Because to add a new to the end of the list in Python are ordered, so recent facts appear last and we can reverse the recency also. So to keep only the last 50 facts to prevent unbounded growth on the memory, okay. So what we can do like, okay, memory of facts, right, and minus 50, it's equal to memory is equal to memory facts, okay, is equal to this, like this, alright. Why is this so? Because this minus 50 like this, okay, like this, it will slice means the last 50 items without this cap. The memory file grows forever. Old facts become less relevant anyway because recent ones matter the most, right? So we are only remembering the 50 facts, so it will be enough context to be useful, so small enough to stay fast, right? After that await, then called save memory function with memory, okay, await save memory async function must be to ensure like okay if it is complete or not. Okay, before the function returns. Without await the save might not be have finished before the caller. Okay, all right. After all, now we will have another function which is async def add topic, right? Topic is like this, str is there. Okay, return is none here. It will be similar. Alright, topic, just a minute guys, I will be back. Alright, so right, we are here. We can add this like some similar to this. Let's just like we will load the memory first, then after that we will make a new topic. What new topic? Then memory facts, append the new topic. Okay, then I will say memory, something like that. Same, very similar. Okay, so let's just go for it. Record that a topic has been covered. Okay, args are like topic. The topic that was just written about. Okay, just like that. Alright, then we have memory. First we will load the memory. Alright, after loading the memory we will add a if a topic not in memory. Okay, topic covered in this. Okay, it is not in this, then only add if not already in the list, right? Prevent the duplicate. So if X is not in the list, it auto can find, but for small list you just set if it is large collection, right? So for that what we do, memory topic covered is dot append the topic. Okay, and right, memory topic topic covered. Alright, equal to memory topic covered, which will latest 100 only. Okay, so same principle as the cap. So after that await, save memory. Alright, this is how we do. And similarly we can add you to the preferences also. Some very same function. Async def update like preference str and value str. Okay, it will return it to us to none. Alright, tell about this function, like what is this all about, right? Like it updates a user preference in memory. Okay, alright, args are like this. We will have a key reference name. Okay, like example depth, then it will use the tone, format, like this, right? Then it will have some value. Okay, value will be like reference value, for example, like expert like, okay, it can have casual, it can have listicle, right, like this. Okay, similarly we will also do memory equal to load memory. Okay, after loading the memory we have to use this await function also. Okay, because we are using the async there. Then memory preferences, right, key equal to value is value. Okay, and then we will have update at will be like, okay, date time dot date time dot now dot ISO format. Okay, alright, then okay, it will keep track of the preferences where it was changed, where it was not. Then after adding this await save memory. Similarly async def get memory context. Okay, str, this is for it will returns a formatted string summarizing all memories. Okay, memo RIES, like this is injected into agent instructions, right? So the agent knows what it has learned